Hi there. I've been working on an enhancement to GSSquared I'm pretty excited about. Probably more than I should be, but what the heck. I've implemented emulation for the Videx VideoTerm. Now, this was a third party 80 column card for the Apple II and II Plus. When the IIe came out, of course, it rendered cards like the VideoTerm obsolete because 80 column functionality was built into the IIe and later Apple IIs. Uh, that's kind of a shame because the Videx VideoTerm had some really cool features actually. So let's take a look. Uh, just like with the IIe and later, you go into 80 column mode with good old PR number 3. Now, first, check out this text. This text may look a little different to you compared to the Apple II, normal Apple II text, and that's because it uses a character matrix that's bigger than the standard Apple II character matrix. The regular Apple II character display is 7 pixels by 8 pixels per character. The Videx uses 8 pixels by 9 pixels. Now, it doesn't seem like much, but it let them really make the character sets for this card look a lot better. You can see the characters sort of have better definition, a little more. I find it actually easier to read. And oops, that is weird. What's going on there? Okay. Let's try that again. Okay. Why? That's weird. Okay, let's just do this then. there's a mode I put this in before I started the video rolling, and I don't remember how to get it out of that mode. So we'll just roll with it as it is. It's like a fake lowercase or thing. So anyway, so the character set looks good. You can do some fun things here. So it also lets you have multiple character sets. So there's the standard character set. It's got a bank for alternate character set. In the real physical card, it was basically the original ROM and an additional ROM, and you could buy ROMs from them. They had, they had ROMs for German, French, Spanish, katakana, one for the APL programming language, which uses all sorts of funky math characters. And there's also graphics characters built into the regular character set. The alternate character set I have here is just the inverse text. So you can see there, I hit Control Z 2 to switch back to the normal character set, and Control Z 3 to switch to inverse. One thing I learned about this is it really is set up a lot like as if it was a terminal, like a standalone terminal display attached to maybe to a mainframe. And so a lot of the commands to control the thing were set up as control characters, escape sequences, things like that you might expect from terminals. Of course, you can also program the thing directly in assembly language. This card had 2 kilobytes of video memory for the text, and you had to page through that in 512 byte chunks because they had it mapped into a relatively small chunk of I/O memory. But it would be pretty easy to directly manipulate the video screens on here to do all kinds of cool stuff. Just like you do with regular Apple II software whacking on the display directly. So let's see, some graphics characters. I'll just give you a sample of some of these. I'm typing Control Z and then a sequence. It's like Control Z, Control E, Control Z, Control D. And so there's a number of these, and you can build stuff out of them. Like I said, there's also that. They also have a character set that mimics all of the Epson printer block graphics characters, which themselves were taken from the TRS-80. So this card would have let you make your Apple II screens look just like a TRS-80 with, you know, like double line borders and all kinds of cool stuff that they had. Of course, the IBM PC ended up with a lot of those cool text mode graphics characters that they did a lot with. We were always limited on the Apple IIe, and later they did come out with mouse text for the Apples, but those graphics symbols were relatively limited compared to the TRS-80, Epson, and Videx VideoTerm. So I'm going to show you a couple cool little things here in terms of directly manipulating this. So you'll see here I've got a blinking underline cursor. That's actually not the normal cursor. The normal cursor is this. And I broke my code, so let's see here. Oh yeah. I'm going to type in a little assembly program here. Let's see. Make sure that's right. That looks correct. Oh, except it's 801 OA. Okay. So this is the normal cursor here for the Videx VideoTerm. It's a block cursor. It's blinking. You can change the cursor blink rate just by changing a value you store into one of its registers. So I'm going to do that. And now it's blinking half as fast, right? So that's cool. You couldn't do that on a standard Apple II. We can change the cursor to not blink. There you go. You have now just a solid block cursor. We can change the cursor size, right? So this is currently the full character. We can change this so that it is just part of the character. So let's do that. Put it back in blink mode. So I set the cursor now to be an underline, right? You can change it. So let's do 68. Right now I've made it really thin, just a single pixel underline. And that's cool. And it can be whatever you want. Like you can have it start and stop on a particular row. And then you can have it blink or not blink. So I kind of like this non-intrusive kind of underline cursor. And honestly, that was one of my favorite things with, you know, Apple II software that did custom graphics for text simulation, like putting text on the graphics pages, is that you could do stuff like this. You could have cool cursors. Well, here you can do cool cursors with the performance of text mode. And that's it. So, of course, Control Reset switches back to the standard Apple II video. You can also do a Control Z1, I think. Yeah, I get the syntax errors because I'm typing into the AppleSoft prompt all these control sequences and it doesn't know what to do with them. Like it processes them, it just doesn't know what to do. So syntax error. Control Reset, of course, will turn the thing off. I need to add an if to the code so that it'll turn on and off automatically when you. Oh, yeah, that's interesting. Oh yeah, right here. it's supposed to switch automatically to graphics mode when you do that, but I haven't done that yet. That won't. That'll be in there before I release the code. So what software could do this? Well, you're already seeing, some software in here. AppleSoft, ProDOS. Let's go ahead and boot a ProDOS in accelerated speed there. There you go. I turned up the accelerator to, you can see down here, effective megahertz. This is a little debug thing I've got going on. Let's see, is there a basic program I can load? Yes. View README. Right? Looks good. The AppleSoft listing goes over to the edge of the screen. Like, I'm not sure how they did that, but it seems to work pretty well. You can do all the normal stuff here in 80 column mode. But what about applications, right? So apparently you could get AppleWorks to work with the Videx VideoTerm card with a pre-boot. Actually, I take that back, with like a patch. So there was some sort of patch that you could apply to AppleWorks to make it work with this 80 column card. There were pre-boots maybe for VisiCalc, where you would boot a Videx utility disk first and then run VisiCalc, and then VisiCalc would be using the 80 column screen. But there were a few programs out there that did support the card natively, and I dug one of them up. It's called ASCII Express, and it is a telecom communications program, like, for modems, dialing into bulletin boards and all that kind of stuff. So I'm booting that here, and you'll see it has switched directly into the Videx 80 column screen. So that's cool. Now, unfortunately, I don't have any serial port emulation in this thing yet, so I can't get us connected to one of these new Telnet accessible internet BBSs. But that'll be the next little project here. So anyway, there you go. Videx VideoTerm emulation for GSSquared. Hope you enjoyed it. Have a great day, and like and subscribe, because if you don't, some unspecified negative consequence is going to occur. That's what's going to happen. So don't let that happen. Like and subscribe.